Here I do more trigonometry. Section 1.4, solving trig equations. Oh dear, I've got to restart this for some inscrutable reason. There. Solving trig equations. Let's see. Okay, only 12 problems, but the word only is suspect. Anyway, proceeding forward. Without using a calculator, find the solutions to the following equations if an interval is given. Find only those solutions that are in the interval. If no interval is given, find all solutions to the equation. All right, so I better really take these one at a time because these are sensitive and subtle things. So immediately I turned it into sine of 3t equals 2 equals a half. I recognize that I know that sine of 30 degrees is a half. And let's see here. Let's see. Let's try and think about how to do this. How to do this efficiently. Like immediately. So immediately we can say t equals 10 degrees. But we want to capture all solutions. We want to capture all solutions. So let's see. If it were just t by itself, right, let's think. $30 degrees or 150 degrees. Now, how to precisely do this? So we could say it's how to do this. Right. Let r equals 3t. Then r is 30 degrees plus n 360 for n or 150 degrees plus n plus 360n rather. That's how they usually say it. Isn't that right? And now how to take care of this for the fact that it's actually 3t. So wouldn't that mean that t is 10 degrees plus 120n, or would be 50 degrees, wouldn't it? Plus 120n. So I think that's how you do it. We're going to really defeat these and take them slowly and seriously. Let's see if our solution works. Oh, so doing it all in terms of radians, even though no one likes radians. All right, so yes, they do that. All right, working in radians henceforth, but that was done correct. Done correctly. And I guess the intervals in the other questions were a sign that I should have been working radians. But anyhow, now to take care of this. Four pi over 3 is not sure why this is taking so long. 240 degrees. That's great. That's strange. Why it's taking so long? $10 degrees and 130 degrees from that. And then 50 degrees and 170 degrees from that. So I think it's those four. But of course, they'd want them expressed in terms of pi, or in radians rather. So I'd say pi over 18. Ten pi over 18, which is 5 pi over 9. You should get them in order at least. Five pi over 18. 13 pi over 18. 17 pi over 18. And I think that that's the answer. We'll check. All right, that's fine. Okay, so the third one. All right. Okay, so it looks like they're not just completely randomized, but they're connected to each other. So straight away, we move the root 2 to the other side and divide by 2. So cos x over 3 equals negative root 2 over 2. So Let t equal x over 3. Three pi over 4 and 5 pi over 4. Three pi over 4 and 5 pi over 4. And then this is plus 2 pi n. And this is plus 2 pi n. And then setting t to x over 3 and solving. In other words, multiplying this by 3 and this by 3. But they will probably want that, within the principal range somehow, probably. But we'll see. No, that's actually quite okay. It's quite okay. Very nice. Okay, for the fourth problem, we're to find values of x within that range. Oh, I should say. So I suppose 9 pi over 4. Now, that already exceeds 2 pi. So if I add 6 pi n, I will go past the range. But if I take 6 pi n, then it'll be negative 6 pi n plus 2 1/4, which is negative 3 3/4. Which is negative 15 over 4. Pi. And then here we encounter the same sort of issue, but not forgetting the initial 9 pi over 4, which is fine. And the 15 pi over 4 here would be fine as well. But then if we were to add 6 pi, then we would surely be on the range. So once again, we have to subtract 6 pi. So this is 3 3/4 of pi. So I take away 6 and I get negative 2 1/4, which is negative 9 over 4 pi. So I guess I should have figured these out based on the evenness of the cosine function, but you know, point is that I think I have them. Now we'll see. All right, we have them. Excellent. Time to try the fifth problem. Okay, set cosine of 6z equals root 12 over 4. Root 12 over 4 is, of course, 2 root 3. 2 root 3 over 4 is root 3 over 2. So let t equals 6z. We recognize that root 3 over 2 is cosine of 2 values within the principal range. But hold on a second now. We have this business to worry about. So probably best to find some multiple acceptable values, is it not? So let's see, root 3 over 2. Okay, so that's 30 degrees, but I know they don't like degrees, so it's very frustrating working gradients. Pi over 6. Two pi take pi over 6 is 11 pi over 6. Let's see, how can I be systematic about this? So then we would get multiple solutions outside of this range. So let's think here. So it's literally 2 1/6 of pi, 4 1/6 of pi, and so on and so on and so on. Anyway, then I'll do just a few of these. I think that's right, isn't it? Yeah. Now, if t is equal to these, then z is a sixth of all of these. And then we have to stop when we get out, when we exceed pi over 2. So when we exceed 18 pi over 36. So it should just be these four here. I would believe. But we must check. Everything must be checked. Okay. We're in agreement about those. Oh, but of course that exceeds 18 pi over 6 over 36. So that was meant to be excluded. But I should explicitly note the exclusionary criterion before crossing things out. Okay, I'll take that forward into the future. All right. What do we do? So we say sine of 3y over 2 equals root 3 over 2. We let t equals 3y over 2. Then we're considering sine of t equals root 3 over 2. We recognize that as an exact value, but notice the solution domain, the domain of y. Well, what do I do? Okay, so that's what we do is we just obtain some values going behind to the negatives. Okay, so root 3 over 2, what's that? Well, that's 60 degrees, which we're not allowed to work with, so it's pi over 3. So it's negative pi over 3. Negative pi over 3. I suppose negative 2/3 of pi as well. Yeah. No, wrong. And we're going to get this. Working in radians is such a pain. But okay. Negative 4/3 of pi. And negative 5/3 of pi. How about that? All right. And then repeatedly subtract negative 2 pi. Repeatedly subtract 2 pi. So, okay. Which amounts to subtracting 6 on the numerator. Likewise here. And now consider what y is. If 3y over 2 is t, then t is 2/3 of y. So I need to find 2/3 of each of these. So multiply them all by 2/3. All right. So -8 over 9 pi. -20 over 9 pi. -32 over 9 pi. Down here, -10 over 9 pi. -22 over 9 pi. -34 over 9 pi. And what is this with 9 as a denominator? -21 over 9 pi. So who exceeds that? This, this, and this. And therefore, these are the solutions. Or so I believe. So I believe. And let's check. Okay, so, well, at least we have 9 on the denominator. But what's going on here? Oh no, you're kidding me. I dropped a minus sign at the very beginning. Fine. This will lead to sort of like a cascade of errors. But while it's still fresh in my mind, I might be able to patch it up. Okay, so let's think. All right, so T would be -60 degrees and -120 degrees, but that's not allowed. So we convert it into radians. So -pi/3 and negative 2/3 of pi, surely. Okay, so just going to do that. And then subtract subtract 6 from the numerator again and again. And again. And here. And again. That might be enough, or it might not. I don't know. And then 2/3 of these. And 2/3 of these. And then who is excluded? So it was -21 over 9, wasn't it? Yes, it was -21 over 9. So that one is, and that one is. And so these are the sort of rescued solutions. And see if they're correct. And they are. Great. All right, so that's fixed. Okay. When you make a mistake, fix the mistake. So I move 5 to the other side, so I get 8. Divide by 8, get 1. So tan of 2x is equal to 1, which I like. So let t equal 2x. Did I do that right? I hope so. Yes, okay, that's fine. Okay, so tan of t is equal to 1. So t would be pi over 4. What next? Okay, I suppose pi over 4 and negative. No, try. Well, just... Oh no, it doesn't have two solutions. Of course it doesn't. All right, so yes, pi over 4, 5 pi over 4, 9 pi over 4, etc., etc. All right, so that's fine. Of course it doesn't. Yeah. Hold on. Okay, that's fine. Just a few values. Oh no. And then you have to go into the negatives as well. But that should be okay. Just take away 4. So minus 3 pi over 4. Isn't it? Yeah, I think so. Minus 7 pi over 4 minus 11 pi over 4. Just one more for luck. And now to actually solve it. Okay, so if t equals 2x, then x is equal to t over 2. And so all of these must be divided by 2. And so they're all going to have 8 on the denominator. So make these have 8 on their denominator. So it goes from negative 4 pi over 8 to 12 pi over 8. And so it has to be within there. All right, so these must all be divided by 2, and so multiply the denominators by 2. 5 pi over 8, 9 pi over 8, 13 pi over 8, and the next set, negative 3 pi over 8, negative 7 pi over 8, negative 11 pi over 8, and negative 15 pi over 8, and solve. So who is included? Everyone but him, and everyone but these. So I think those are the solutions. And now we check. Everything must be checked. All right. Okay, that's good. That solves it. Next. Okay, 20 on the left, 20 over 20 over negative 9. What on earth? I'm sorry, am I actually thinking correctly? Is this a misprint or... Because he said exact solutions. Okay. It was like a trick question type thing. Right, okay, so sine of 7x is equal to 20 over 9, which is impossible. Right, okay, I should have thought about that a little bit longer before checking, but anyway. Right. Has no solutions. As the range of sine of x is less than or equal to 1. Okay. Take away 5 and then divide by 3. So negative 1 over root 3. Negative 1 over root 3. So this is tan of t over 4 equals negative 1 over root 3. In that interval right there, so let x equal t over 4. Then x is equal to what? Well, that's 30 degrees, isn't it? Or pi over 6, beg your pardon, but that's only when it's positive. So take pi over 6, which is 5 pi over 6, plus pi over and over. Is that the right thing to do? It seems so. Oh, wait, that's not right. Maybe some more. I mean, there is a systematic way to do it, but here, because the intervals are particularly short, you can just get a few values, like when calculating the HCF or LCM of a pair of numbers. So that'll do. Now, if x is equal to t over 4, then t is equal to 4x. Therefore, these have to all be multiplied by 4. These have to all be multiplied by 4. Which is the same thing as multiplying the numerator by 2 and turning the denominator into 3. That's right, isn't it? Because that'll be 44 over 6, so yes, that's fine. So 34. And wait, perhaps figure this out first. All right, so 4 pi is 12 pi over 3, is it not? So I've already gone too far. I don't need these. Feels a little bit too easy though, but maybe that is just the only solution. But we'll have to see. Right, okay. All right, now for problem 10. Okay, so I'll add 7 to that, so I get 2 over root 3. 2 over root 3 is cosecant of 9z. Well, cosecant is 1 over sine. So sine of 9z equals root 3 over 2. And we know that's 60 degrees, which is not permitted, so pi over 3. Pi over 3. Now, we have this range here to contend with. So a few negatives, so a few positives and a few negatives, that'll be just fine. Okay, so it's pi over 3, and what's the other one? 2 pi over 3. And then just add on 2 pi a bunch of times, which is the same as adding on 6 to the numerator a bunch of times. So 7 pi over 3, 13 pi over 3, 19 pi over 3, and then take away 6 from the numerator a bunch of times. So minus 5 pi over 3, minus 11 pi over 3, minus 17 pi over 3. And same thing here, I guess. Okay. Take it away now. What the hell? Right. Now, perhaps, yeah, so just imagine 9 or 27 on all of their denominators, and then make this have 27 on the denominators, because I don't want to do all that writing. So that's going to be negative 9 pi over 27, and that'll be to 12 pi over 27, like that. And so who is excluded here? So kick off all the ones that are greater than 12 pi over 27. Oh, wow. Okay, so that one. Oh, right. Okay, that one. And then all those that are less than negative 9 pi over 27. So that. that. Okay, so I have 6 solutions. Pi over 27, 7 pi over 27, 13 pi over... Wait. Hello, that one has to go. Okay. Negative 5 pi over 27, 2 pi over 27, and 8 pi over 27. I think they all work, but we'll soon see. Great. That's correct. Wait, no, it isn't. False. We got 2, 7, and 8. But where is 4? How is 4 missing? Because it was erroneously excluded. And now include. And check. And that's correct, and that's good. Okay. Problem 11. Okay, take off the 1, divide it by negative 14, and we'll get a half. So cosine of 2x over 5 is equal to a half. So what does that mean? Let t equal 2x over 5, then t can be pi over 6. No, it can't. No, you're not doing that right. Pi over 3. It is pi over 3. And it's 5 pi over 6. 5 pi over 6. No, that's not right. Just write it out. It takes way too long for me to do this, so the only solution is to just get better, but how? Anyway, it's 60 degrees, so turn that into radians, yeah. So pi over 3. And who else? Who else? Who else? Take away pi over 3 from 2 pi. That's all you have to do to get the other one, to get the other side of the valley. So 2 pi take pi over 3. So 1 2/3 of pi, which is 5 pi over 3. And that's enough. But now you need all of these, don't you? So add 6 to the numerator over and over and over again. So how am I going to do this? I'm going to do it like this. This is a bit unorthodox, isn't it? No, I don't think I want to risk doing that. So, not at this point. There must be a more efficient way. Just think it through like that. I don't know. I really want some way in which I just merely list the integers and then I just have to transform them. That'll be better. Fewer moves, fewer actions. That will do. I'll invent more if I need more. But it's the same for this. And backwards. Oh no. Oh no, no, no. Oh, I see it. Okay, so if t is equal to 2x over 5, then 5t over 2 is equal to x. Multiplied by 5. So imagine 6 in the denominator. Right, so get this with 6 in the denominator. That will be 30 pi to what? To what? To 80 pi. Really? Really? So if I had just thought about it, I wouldn't have done any of those negatives at all. Completely worthless. But that's the price of habit. Not thinking. Okay, anyway, I think I can get this now. I'm just going to focus on the numerators. 5. The coefficients of the pi in the numerators. So 5, 35, 65, 95. And who is acceptable? Only these two. And then for these, 25, 55. And who is acceptable? Only these. So only these, and only these, and transform them as you want. Come on. 35 pi over 6. 65 pi over 6. And this one. 25 pi over 6. 55 pi over 6. And check. Nearly, if you had only thought that clearly this would be excluded. But otherwise, okay. All right, that's good. Okay, last one. So I'm going to take away 2 and then divide it by 4, so I get negative a half cosine of y over 7 equals negative a half. And this time I'm going to pay attention to the domain of y. It's 10 pi to 15 pi, so don't do those negatives. All right, and by now you should know that t equals y over 7, then t is equal to what? Come on, compute. Just takes so long, doesn't it? Right, so if it has to be negative a half, then it has to be 2/3 of pi. That's one answer. And what's the other answer? Do 3 over 2 pi take 1 over 6. So what? 9 over 6? Take 1 over 6, so 8 over 6, so 4 over 3. And then think about the transformation. So just add 6. And just add 6. And then t equals y over 7, so y equals 7t. So multiply the numerators by 7 in each case. And transform this. So 10 pi is what? 30 pi over 3. 15 pi is what? 45 pi over 3. So by 7, by 7, by 7, by 7, like that. So 14. Just one more. By 7, not in range. By 7, it is in range. By 7, it's out. By 7, not in range. By 7, not in range as well. So I do think that the only solution is (56 pi over 3). I think. No. Wrong. That's wrong. Why? Because just look at it. Okay, fine. Try again. Okay, 14 there, 56 there, and 98 there. So none of those. 28 there and 70 there. So none of those. So I think it has no solutions. Or so I think. But so we'll see. Okay, that's correct. Okay. Who's next? Oh my goodness me. The worst calculator among all of them for this job. So I'll have to do something different as well, because otherwise I'll start making mistakes if I do too much of the same thing. So what can I do that's different? Some linear algebra? Something like that. I'll think about that. Be well. Be well.